Hello, everyone. This is Screencast number 2 for week number 3. And more than likely, this screencast will be broken up into two 20-minute chunks. So let's take a look at different types of studies. So the purpose of this week is to analyze the types of studies utilized in epidemiologic research. Here's the plan for the week. So we've got a discussion topic. So that is a continuation of what we started in week number 2. You have a homework assignment due on the 25th. Also, make sure you note that the discussion topic, I want you to have responded to your cohort members by September 18th. You've probably already listened to the week 3.1 screencast. And we see that there are 3 articles that are to be reviewed, not to be read for understanding all of the material in it. We're looking at these articles specifically to answer some questions in the homework. And again, we've got a very diverse group. I use a lot of orthopedic, physical therapy, or athletic training literature because that's the world that I come from. Again, for many of you, it may be irrelevant to your interests or your professional discipline, but we're able to see how epidemiologic research is used. And that's why I say don't read it to understand the article in depth, but to answer the question. I've got specific questions, and I want you to get something out of the tables presented in those articles or the data presented in those articles. For your response, again, follow up as soon as possible. I would have mentioned that also within the email that I sent out about week number 3. Make sure that you're responding to your cohort, and I'll talk about this again at the end of the lecture. So in the basic epidemiology textbook, it classifies epidemiologic studies as observational or experimental. So you can see some examples there, and we're going to go through these today. Another way of looking at things is epidemiologic research all falls under the quantitative umbrella. There's the experimental side over here. Then remember I said observational. Well, observational epi is right here, and we've got our cohort and case control studies. But in reality, epi also is over here too, under this descriptive component. So what I just wanted you to be aware of here is sometimes it's classified like this. Sometimes it's classified like this. And you're like, well, how is a case report epidemiologic in nature? Well, we'll see an example of that in a bit. So here's what we're going to start exploring. Let's start with the observational studies. And observational studies allow nature to take its course. Now, I don't have this PowerPoint in play mode right now, but if you download it and you put it in play mode, you'll understand why I've got this little video embedded here. Observational studies allow nature to take its course. What you'll see on this video is somebody trying to run backwards on a treadmill. If you're an epidemiologist, you may think that what this guy is doing is very stupid and could lead to injury. But you as the investigator do not intervene. Play the video, you'll see that within a few seconds, he wipes out. Now, under observational studies, if we are following along with the textbook, we're going to be looking at things that are descriptive in nature or analytical. Descriptive, that's basically describing the occurrence of the disease in a population, and it's often the first step. Analytical is analyzing relationships between health status and other variables. Now, descriptive studies, again, limited to the description of the occurrence of disease in a population. Most studies, though, are analytical that often include descriptive stats. Here's an example where we're looking at a paper published in the Journal of Athletic Training, Hootman et al. I believe this is the same Hootman that we've got this week for review. And in Table 1 here, it's publishing game and practice injury rates for 15 sports that were analyzed between 1988 and 2004. So what's being described here? They're describing the exposures. That means the number of times an individual was involved in practice, or the number of times an individual was involved in games. And then they were counting injuries that occurred based upon whatever that operational definition of an injury was. And then they were looking at rates. What is the game injury rate and the practice injury rate? And in this case, they defined it per 1,000 athlete exposures. Now, here is a descriptive epi example. It's not analytical, and it's a case report. Or you could say a case series being a few more than a case report. You know, where does a case report end and a case series begin? I've seen sometimes people publish a case series of 2 people. Case reports, oftentimes we talk about 1, but again, I don't know that there's any hard and fast rule. Here's a case series looking at 4 previously healthy men who were homosexual in the early 80s. Now, think back to the early 80s. If you were alive at that point, there was a disease going around that nobody had a clue what was going on. And in this case report or this case series, what the physician team here is describing is a disease that was happening in a cohort of individuals. This was one of the earliest papers that explored the disease that was later named AIDS. So there was this finding and a description was occurring. There wasn't any analysis as to how this was occurring, what the rates were in the population in general, whether that be a specific population or the general population, rather that it was identifying that this disease was occurring, that it may be occurring within males who were homosexual, and that doctors needed to be aware of it. So, descriptive studies are the first step in epidemiologic investigations. Pure descriptive studies make no attempt to analyze the links between exposure and effect. These studies report things like mortality rates, injury rates, maternal death rates, things like that. And they might examine patterns by age, sex, or ethnicity. Here is another descriptive study example coming from the textbook. So what do we see here? Figure 3.1, maternal mortality rates in Sweden from 1750 to 1975. So what do we see? We see a downward trend in death rates over time. But what does it tell us? We can't attribute anything to the data. We can't say, oh, well, obviously the decrease in death rates are due to improvements in medicine. Well, when did those improvements occur? We would need to do an analysis. Somebody else could say, oh, maybe those death rates are improving because there was better nutrition, or there was less exposure to war, or something else. So this descriptive study is that first step again. Interestingly, you might also want to know, well, why were those blips that occurred in an upward trajectory? As things decreased, for example, around the 1850s there, why did it shoot back up in the 1870s? What was going on at that time? That type of information is valuable to epidemiologists because it can help us understand what increases the risk of death and disease in a population. Here's another one, another descriptive study example. So we're looking at age-standardized death rates from heart disease among men aged 30 years or more from 1950 to 2002. So what do we see? Well, we see a lot of Western countries with death rates that are quite similar. And then we start to see a decrease in the death rate that occurs, maybe mid 70s, definitely starts shooting down in the 1980s. So we see a pattern there. We can't say why that occurred, but we can start to speculate. Was there a better understanding of diet at that time? Was there a better understanding related to the relationship between cigarette smoking and heart disease? Were there improvements in medicine that saved lives at that point in time? Well, what caused the death rate to continue to drop into the 2000s? So again, a lot of speculation that you can make there. What was different about Brazil? Brazil has had, per their data that was available since the early 80s, a low death rate. What was different in Brazil versus those Western countries? And then you can look and see, like at the Russian Federation, why did their death rate stay high, which was similar to Western countries, and appeared to increase over time? What was going on during those periods of time? Were there things like, I don't know, some of the craziness that was occurring with, I believe, Boris Yeltsin at the time, and the switch over from the Soviet Union to the Russian Federation? There was a lot of economic instability. Were people drinking excessively? You could speculate that and how that contributes to heart disease. Were people eating poorly? Was there a lack of access to life-saving medical resources? So again, it can be this fascinating exploration. You can speculate, but you can't say for sure. Next, looking at an ecological study, also known as a correlational study. So these are useful for generating hypotheses. The units of analysis are groups of people rather than individuals. So here's an example. What's the relationship between average sales of an anti-asthma drug and the occurrence of an unusually high number of asthma-related deaths? So in this asthma drug example, this observation would need to be tested by controlling for potential confounders to exclude the possibility that other characteristics did not account for the relationship. Ecological studies can also be done by comparing populations in different places at the same time or in a time series by comparing the same population in one place at different times. So here is a time series example. This is illustrating the deaths during the heat wave in Paris, France in the year 2003. So what do we see here? We see that there was a correlation between increasing temperatures and the number of deaths or excess deaths that were occurring. We're able to see that. So this is an example of an ecological study. Strengths to the ecological study: it's simple to conduct. Weaknesses are: it's difficult to interpret, seldom possible to examine directly the potential explanations for the finding or findings. Often these studies rely on data collected for other purposes. So there's data that's being looked at on different exposures and on socioeconomic factors that may be of interest that might not be available. The unit of analysis is on the group, so a link between exposure and the effect at the individual level cannot be made. Why were there excess deaths? We see that there was an increase in temperatures, but what were the risk factors in addition to temperature? Were these all individuals that were older? Were these individuals that were immunocompromised? Did these individuals lack access to air conditioning units? There was a heat wave that came through the Portland, Oregon region and parts of the West Coast a few years ago. Portland hit 118 degrees on one day. We do get hot, but not that hot. And there was around 100 plus deaths that occurred during that 3-day span that were considered deaths due to heat. A lot of the apartment complexes in the area that supply affordable houses for those with lower socioeconomic means lacked air conditioning. So again, you get some valuable information, but you need to dive in deeper to explore what are the potential risk factors associated with that heat exposure. Hopefully that makes sense. You don't see a lot of ecological types of studies within physical therapy and athletic training research. Maybe it's something that you'll see within your discipline. So looking at a fallacy or bias of ecological types of studies here, this results if inappropriate conclusions are drawn on the basis of the data. Bias occurs because the association between variables at the group level does not necessarily represent the association that exists at the individual level. Here's an ecological bias example. So, figure 3.4, neonatal and maternal mortality are related to the absence of a skilled birth attendant. So, we see the percentage of births without a skilled attendant, and we see it's high there in some countries, some regions, Eastern Mediterranean, Southeast Asia, Africa. So some areas are high there. Then we track maternal mortality per 10,000 live births, and we look at neonatal mortality per 10,000 live births. And what do we see? Well, we see that in those countries that have a higher percentage of births without skilled attendants, we see what appears to be a higher maternal and neonatal mortality. But if we look within the groups there's one group which appears to have a lower death rate. So a lack of a skilled birth attendant there is not necessarily a reason why. And it may mean that there are other reasons, like why is Southeast Asia and Africa just skyrocketing? What's going on in those areas compared to the others? Cross-sectional studies, we discussed those last week. It's a measure of the prevalence of disease or injury or the outcome of interest, typically at one point in time. You can, though, have serial cross-sectional studies. A key question with these is cause and effect. Does the exposure precede or follow the effect? Here's an example of a cross-sectional study. This is a made-up example. Let's say you were curious about the prevalence of steroid use because that can potentially be unhealthy for individuals. And you're specifically interested in looking at Major League Baseball players. Well, if you had data from 1990 and you took data at one point in time there, you might find that 5% of the population was using steroids. You can do repeated measures or a longitudinal type of study and look at things over time. So you could assess the prevalence of steroid use and see how it changed over a 10-year period. And again, all made up data here going from 5% to 30%. The strengths and weaknesses of prevalence studies, again, they're important for planning health services. They provide valuable information about what to expect in different clinical situations. They're less time consuming. They're inexpensive because you just collect all that data right there and you don't need to follow people over time. But they're only weak evidence for cause and effect. All right, I think this might be a good place for us to stop. We're 20 minutes in, and when you're ready, pick things up for the next section.